Good?
Yeah.
Okay, yeah. Sound all right too. Everyone, my name is Phil Ngo. I'm the project manager over at the Lodestar consensus client. We both work at ChainSafe. And then I'll let Nico introduce himself.
Yeah, hey, I'm Nico. I work on Lodestar as a developer, and yeah, more on the technical side.
So before we start this, how many of you guys know what actually happened to Holesky at all? Some hands? Good. Good, okay. Say like half the people here. Okay, well, we'll enlighten the rest of you and basically go a little bit more into detail and fill you guys in on a little bit about what happened here. So we decided to start the slide with some of the our infamous quotes here, I guess, at this point. I think we may have forked, everything is on fire. So that gives you a good rundown to start. So basically, the TLDR here is that Holesky justified an invalid execution payload, which involved the deposit contract. It had an incorrect deposit contract address, so we ended up justifying a execution payload with the wrong deposit address, which leads to really bad things. The majority of the validators followed that invalid chain, and we had quite a bit of difficulty trying to rescue the valid minority chain of the forked Reth and Aragon clients, which had the correct deposit address. Okay, so next up, why is client diversity meaningful to Ethereum, and why does it matter here? Well, as you can see, liveness. So for a period of time, it was quite unusable, if usable at all. So by reducing client-specific implementation risks, so we'll go a little bit further in depth about some of the other clients and what may have happened to them on Holesky, but bad things like out of memory, DDoS, and of course, like that kind of stuff leads to very bad outcomes on the network. Fork resistance, of course, reducing the risk of the validators from finalizing that invalid chain as well. As you know, like we have 6 now different consensus client teams, so they're not all built the same way. There are different implementation details between each of them, and that actually gives us quite a bit of engineering diversity, also the language diversity between the clients, and some of them even have experimental things on there, which some developers benefit from. Decentralization in the decision making. So as a majority type client, you can almost say like you de facto kind of control what the spec is because the majority of you are following that implementation. So by having client diversity, you also help with the diversification of decision making. Minority clients are important. As I mentioned before, Reth and Aragon were the ones that were actually following the correct minority fork. I mean, how many of you even run Reth or Aragon nodes right now? So that probably goes to say, good on you. All right. Yeah, so not many of you. So that goes to say, like we got to do a little bit better there in terms of client diversity. And of course, spec interpretation and discovering ambiguities in specifications. You look at a specification, some may interpret it one way and some might interpret it the other way. You'll find sometimes that we will find spec edge cases because somebody implemented the spec in a certain way because that's how they read it. So we help find some of these problems as minority clients. And of course, it's only as good as the people who run the minority clients. So right now, Lodestar is about 2% of mainnet. Even if something bad were to happen there, and we, were basically on a valid minority chain, it'd be very difficult for us to really help there as 2% of mainnet. So very important for you guys to consider minority clients as part of your setups. If not primary, at the very least, a secondary option. And we'll explain why.
So let's look into what are the problems that we encountered on Holesky, and later we will show different issues that each client had different issues. But this is like mostly from our point of view first. So like there were a lot of memory issues, because like non-finality, it adds a lot of stress to the client. It needs to follow multiple forks. You cannot prune old states. You need to keep the fork choice blocks. So you have a lot of blocks in the fork choice because they are competing chains. And especially in Holesky, the issue was that the majority chain, which the majority of validators voted for, was not the correct chain because it had an invalid deposit contract. So we cannot use this chain. So we had to find a way to verify the correct chain, which was difficult because the client by default will always choose to follow the invalid chain due to the maturity. And it was also difficult because the majority of the nodes were on the wrong chain. So you basically peered with nodes that you basically didn't want to peer with. And yeah, like the huge amount or the low amount of healthy nodes synced to the right chain made syncing really difficult. And you can see a few images here where we had like a memory bug which caused huge memory consumption, and eventually the client OM'd. We fixed that later to be able to sync. And the last issue was because it was an execution layer bug, it was not possible for the CL itself to validate the invalid block even after you patched your execution client, and either you switched to Aragon or Ref, or you ran the patched, for example, Geth client. But if you didn't have a running client at the time, it basically got in the mode where we imported the block optimistically due to optimistic sync, and we didn't even follow the right chain. And the EL was like stuck in this optimistic sync mode and never rejected the invalid block. So a few solutions we had to come up with here was we needed a way to tell the client that the majority chain, which was invalid, is not the chain we want to follow. So the solution here was just to blacklist the invalid block root, and that way we forced the client to follow the right minority chain. And basically then there was like this battle where we had to get nodes synced to the head of the chain, which was really difficult. And yeah, there were several things like serving checkpoint states. So I will later explain this more, but we added a functionality to sync from an unfinalized state, which is usually not safe, but it's like if you need a last resort rescue option, that is still something which can help there. And yeah, basically the goal was to get as many nodes on the minority chain as possible. There were like other fixes we need to do because there was a huge period where no blocks were proposed at all. I think up to 600 slots, and our client basically by default, due to safety, considers itself syncing if it doesn't see blocks for 32 slots. So we had an option. We had this before, but for example, yeah, you had to set this higher limit so that actually someone proposes a block on the chain. And once we had more blocks built on the minority chain, it was then also way easier to sync the chain.
Yeah, so one other thing to add in here was it's very difficult to coordinate this because everybody is kind of on their own fork almost. So a lot of times we're in Discord basically and just trying to like message people's like, all right, who's got like the highest head right now? And trying to figure out, like who's on this fork that is moving along with a valid minority chain. So even the coordination aspect of it was difficult.
Yeah, and basically the last point was also big, that once we shut down all the nodes on the wrong chain, once most node operators did that, then you started to get syncing into a healthy state again. Because those nodes fed bad blocks and bad data, which we then had to downscore and disconnect, but this caused a lot of trouble for the client to sync.
Yeah, so yeah, as you heard from Nico, maintaining liveness was very difficult. There were times where we didn't see blocks for hundreds and hundreds of slots. So the main goal really in a troublesome network like this is really we got to align on socially on a valid minority fork, getting consensus on that and spreading the word, and also you'll see as with like unfinalized checkpoints to get people onto the right chain. We needed to build up enough healthy nodes that were synced on this minority chain so that we can get validators proposing on it to bring back liveness, proposing blocks. So you know, whose chain was the furthest? What's your block root? What's your block number? Start building as many blocks as possible. The goal was to try to get 75% of the slots in an epoch with a proposed block. So you can see how difficult this is with a bunch of different validators and stuff run by multiple different entities. And then, of course, if you do have a synced node on that chain, we wanted to spread the word. So giving out your ENRs of that will help bootstrap some more nodes to connect to you, which is, you know, another problem. We didn't have enough synced nodes on the proper chain, which also is like a DDoS vector because now everyone's trying to connect to that one to get data from. So that poses another problem.
So yeah, there were several solutions how we address this to get the nodes to sync better, to just get back to the head on the right chain. So the one thing that really helped a lot was syncing from unfinalized, which I quickly mentioned before. Basically, this allowed us to this was like really important after 2 weeks, because I mean the sync speed basically got harder and harder, and you always have to start from the last finalized checkpoint. But yeah, we added options to pass an arbitrary checkpoint state to sync from, and then also we added APIs that you could fetch this from a online node that you knew was following the right chain, to get like back to head in like minutes instead of days or multiple hours. Like the sync speed was really slow when the non-finality was up to 2 weeks. And other things were like just to get more blocks proposed. There were like people opening up their nodes. Like we also opened a bunch of nodes to the community so they can connect until their node is syncing. They would connect their validators so they propose blocks on the right chain, which helped a lot. And there are other feature ideas that were floating around. To mention one of them was like have a feature in the client where you just give it an ENR, where you say follow this node, whatever this node is on, which chain. Because like the problem as we mentioned was there were many minority chains and there were barely any votes. So it was hard for the client to even pick, and you had to coordinate like on the social layer to figure out what minority chain we actually want to follow. And right, so then during the end, like there were a lot of different options we considered how to actually recover this after we achieved the goal. Like we got the chain into a stable state, and there were a lot of blocks, but the majority of validators still didn't do any attestations because they initially voted for the invalid chain. So that means if they would vote on the other chain, they would do a surround vote, which is a slashing penalty, which means those validators would be slashed and ejected from the chain, so also not contributing to building blocks anymore. So by default, the slashing protection prevented this. So we were building blocks, but not attestations. But to recover the chain, we had to finalize it again. And for this, we needed attestations. So this is like the second option here, like just slash the validators. So they are ejected, and eventually the chain will like bleed out. So the validators that are slashed get ejected, and the validators that were on the right chain that didn't violate and won't be slashed would eventually hit the 67 or 66% threshold to finalize the chain. But this process takes a long time because it takes several weeks, up to a month, for this to happen. But we wanted to recover it faster. So one thing which I mentioned before is like we just shared nodes. So people that didn't have a sync node could connect there. And then we basically tried to get all the attestations in at one time or during 2 epochs to finalize the chain. And like this is a picture from the Eve Panda Ops node. They spawn up like huge nodes that can, or huge servers with a lot of nodes. You can see it's what, like 96 cores and 755 gigabytes of RAM. So these huge, humongous machines were like, because a lot of community members didn't have sync nodes, and there were still a lot of issues. So
Yeah. We just needed to get enough attestations to hit the 2/3 threshold for being able to get something finalized. And what the ETH PandaOps guys did was they just spun up, these super nodes, put in a load balancer, and it was like, if you can't get a sync beacon node, just connect to us, point all your validators there. So I don't know if you can see the writing in this, but yeah, it's like 96 cores, and I think there's 755 gigabytes of RAM. Yeah, something ridiculous like that. So, yeah, so I think you're taking this one, right?
Just like I said earlier, there were like many different problems in clients. One was the memory issue, which we had for a while, but then we fixed our bug after like the first 12 hours. So after that, like our client was following the chain, but basically we also had then disk issues, and other clients had disk issues as well, and memory issues, but it was always at a different time where a client had an issue. So there was always liveness in the chain, because at any point in time you had some clients that could handle the load and gave other teams time to fix their bugs and patch their client basically to get it back online.
Yep.
And this is like just shows that if we only rely on one client, then that has like a memory OOM bug, and that's like widespread, like a systemic OOM, then you could have the scenario where the whole chain just dies because there's like a cascading failure of clients. But due to the different bottlenecks that each client has and implementation difference, you are very unlikely that each client explodes at the same time, which is a huge de-risking of the whole network.
Yeah, so it pretty much explained here, everybody kind of like took their share of helping the network to recover. There was a point in time where it was one client, and then another time where it was like another client, like in this screenshot here. At this point in time, it was Lodestar that was proposing blocks while other client teams addressed their issues. So basically being hedged by running as many minority clients as you can de-risks your setup and actually helps the network recover from these pretty near fatal scenarios. So some ideas for the future. I mean, really, Ethereum could definitely benefit from a lot more unstable network testing. This is not like an opportunity that we get very often. Holesky's fate was a little bit of a fluke for us to really discover this, and just goes to show that we need to do more non-finality testnet type exercises where we can actually test each other's client implementations and how they handle in very unstable network conditions, which luckily doesn't happen very often on a mainnet, but we should always be prepared to be able to handle something like this.
Yeah, and to add to that, like there were like NFT, so non-finality testnets before, but the scale is just different. So on the Holesky testnet, the scale of the incident was just way larger and showed way more bottlenecks. So in the end, like the whole incident was like a huge learnings for each client team and a lot of fixes we did and a lot of future ideas. So it was overall a really great exercise.
Yeah, a lot of client teams came up with different features and enhancements that will be able to help us hopefully recover from something like this a little bit better next time. But I guess the main thing is being able to see how our clients perform in a network like Holesky, which was very well geographically diversified, also diversified by node operator types, different clients. And that's not something that's very easily replicatable with even DevNets that we usually spin up for testing. So that pretty much concludes our presentation, and we just snapshot some great quotes after we finalized the chain again and rescued Holesky. And this was like one public testnet fork away from mainnet or something. Yeah, so yeah, this is it was very timely. So we'll take some questions if you guys got any. We'll continue from there. Thanks.
Thank you.
Thank you, Phil and Nicholas. The first question at the top of the question list is, if this were to happen on mainnet, how much of this rescue process has been documented and it is repeatable if something like this would happen on mainnet?
So like all the features we listed here we added is basically we added CLI flags to address this without patching the code, and all these features are baked in the client now. And I guess the procedure, there was a document from Eve Security which documented some procedures. But yeah, mainnet is a different beast. Like it's way harder to coordinate there, the community. So, but a lot of the procedures, how we could coordinate, are definitely similar.
Yeah, we basically opened up some more options. Like we've created some new tools for ourselves to be able to, deal with situations like this. However, the coordination aspect, of course, is going to be very different on mainnet. You might even have social coordination that might need to be required on a layer 0 type perspective to recover a chain like that. We're just kind of lucky this was on a test net where the majority of validators were controlled by known entities, such as ChainSafe and other large client teams.
Just to remind everybody, if you scan the QR code and log in with your email that you use for Protcol Berg, you can ask questions.
Yeah, but to clarify, like the recovery mechanism we used in the end, it's like on mainnet, you would not be able to do this probably. So if it really happens, which I hope it doesn't, but that we finalize an invalid chain, then I guess the majority of validators would need to either bleed out slowly or get slashed because they violated the surround vote, and yeah. But this is like on Holesky we wanted faster recovery, not wait a month. But yeah.
So another question is kind of around the same topic of mainnet is a very different beast. What would be the differences, or could we make them less different, or?
I would say it's mostly that there are much more operators. It's way harder to coordinate. It's not as easy to just tell in a few channels, can you roll out this image? Because we had to push a lot of, like each client team had to push out a lot of patched images with bug fixes. Like it's mostly a coordination issue, I would say.
Yeah, I would say like the problem also with mainnet right now is 90% of the network is running 3 clients as well. So even if we were to try to help out on some sort of mainnet non-finality type problem, we wouldn't have enough. We wouldn't have very many nodes. Like even the syncing aspect of it was very difficult because the majority of clients were wrong.
Yeah, so I would say for mainnet, the best thing we can do is just get better client diversity. Just distribute the setups, get the 20-20-20 share, like each client maximum 20% of the network. That way, it's way less likely that you have all clients or majority vote for an invalid chain.
Yeah, let some of those devs sleep at night,
There's actually a question here related to this. They ask, do you think there will be some clients, or there already is, some clients specialized for worst case scenarios versus other clients for best case scenarios?
I don't necessarily think so. I think the diversity aspect of how we've implemented and built and architectured our clients is actually the strong suit of everyone. Like we are much stronger together, and not necessarily individually. So I wouldn't necessarily say that like, you know, one client is better than another for something specific. It's very much like we need to be able to help each other when one of our clients go down. So, yeah.
Last question is running out of time. If you had to underline one thing, what is the most important lesson learned from all of this?
Run minority clients. Quite honestly, it really helped make the Holesky rescue a lot easier. And you know, we don't have a lot of mainnet ETH, so we can't really dictate that. So we need your help.